Notice I did not initialize any of the values of the properties. They all have a null value because they are not pointing at or referencing any objects. In the start method, I give these properties a value by searching through the scene for game objects with a specific name. If the game objects are not found, either because they do not exist or because they are inactive, then the value of the property remains null. Now you know what is going on when you get a null pointer exception error. You simply are trying to use a property that has not been given a value. The GameObject.find method returns a game object, and we are just setting our properties that are of type GameObject. When assigning a value to character name text, we do not set it to a game object. Instead, we get the component from the game object that is of type text. While the start method is great for initializing values because it only runs once, you often have other code you need to initialize your scene. Here I add an event listener to the input field which runs an updateName method anytime the value of the input field is changed. I also initialize the text property of the input field component to Mario. I know the text property is a public property of the input field because I am able to directly change it from outside of the input field class. If the property was private, an error would occur from this line of code. Notice I am defining a variable named BGAudioText of type transform inside the start method. By defining it in a method, the variable only exists within the method. There was no reason to make it a class property because the reference to the object is only needed temporarily when this method runs. I am storing only the transform of the BGAudioText because I do not need a reference to the entire BGAudioText game object. I am only using the transform to find other game objects that are a child of BGAudioText. If I attempted to use the GameObject.find method to find the game object with a name of slider, I would have an issue because there is more than one game object with that name. This code allows us to search for a game object that is a child of another game object. Of course, comments are useful. This comment indicates a bug that I have yet to resolve. I would like to set the value of the sliders to be at 0.5f, so the volume modifier for audio sources will begin at 50%. However, calling the update method from the start method is not working as expected. So for now, I am just setting the values for the sliders and toggle elements to the same as the default state of those elements. Because of the event listeners that follow, the update volume method does get called every time one of the values on the slider or toggles is changed, and in this case the method runs as expected. To finish the start method, I call the setHealth method, sending it an initial value to represent 80% health. It may be better to have the player start with 100% health, but I wanted to test that the health meter on the HUD was accurately updating when the health was not full. When the game begins, I am also disabling the settings canvas and calling the show character panel and unpause methods. Under the start method are the getHealth and setHealth methods. Remember, health was a private class property of type float. It was of type float so it could store decimal values, and it was private to prevent other classes from accessing it. However, we do want other classes to be able to access the property, so we are creating public methods to allow them to do so, while allowing this class to ensure any changes are done correctly. So another class may use the getHealth method if they just need to know the value of the property, and it may use the setHealth to set the value of the property. These are called getter and setter methods, and the convention for naming them is to use get or set followed by the property name that is being accessed. The getHealth method returns a value of type float. The setHealth method returns no value, which is why the return type is void. The code inside of setHealth is a good example of why other classes should not be able to directly set the value of the health property. This code ensures that the value is appropriate and makes other changes that are necessary anytime the health changes. The setHealth method is defined to expect a float value to be sent to it. Whatever value is sent will be stored in the variable named h. Normally, you would want a more meaningful name, but in this case, the value only exists in this very short method, so it will not be confused with other variables. The validation code simply checks to see if the value sent is greater than 1, and if it is, it changes the value to 1. 1 represents 100% health, and we do not want to allow the health to be set above 100%. Similarly, if the value that is sent is less than 0, then we change the value to 0. Once we know that H has a valid value, we can safely update the value of the health property to the value of H. The last line of code changes the horizontal scale of the health bar based on the value of the health. If the value of the health is 0.8, then the width of the health bar will be 80%. While the health property is private, the setter and getter methods are public. A setter method is only made available if other classes should be able to change the value of the property indirectly. If other classes do not need access to private data, setter and getter methods for the property are not needed. Because of the event listeners we added to UI elements in the start method, the update name method is called anytime the input field value is changed, and the update volume method is called anytime the slider or toggle components are changed. Notice both of the methods are private. This is because I see no reason that any other class should be calling these methods. I want these properties to be changed only when the player makes changes through the game settings UI functionality. The code inside update volume is interesting, but to understand what is happening you must first understand the volume modifier class. In the editor, select the nature sound game object. In the inspector, we see there is an audio source, so we have attached the volume modifier script. And so there is now a volume modifier object for the nature sound. There is one property that is named type, which has a drop-down that allows the level developer to specify the type of audio as BG for background audio or FX for sound effects. The nature sound in my game is rain, and I set the type to BG. If I click on the rabbit, which also has an audio source, I added a volume modifier and set the type to FX. If I select the FPS controller, which also has an audio source, I added a volume modifier and set the type to FX. I also had to edit the first-person controller.cs script to remove the code that I had placed earlier, which was setting the volume of the audio source. I'll pop over to that script for just a moment. Instead of deleting the line of code, I commented it out. Instead of setting the value through code, you should set the value for the volume of the audio source in the editor. I'll set this to 0.8, so it is 80% of full volume. The goal of volume modifier is to modify the volume of each audio source based on the initial value of the volume set in the audio source.